Okay, we're looking at problem 18 on chapter 3. It's a non-concurrent problem. It's a boom, has a load, a tension cable, and a pin reaction. And it tends to be a little involved depending on where you take moments, so this one can be a little bit difficulty if you're not careful with it. So what we're going to do is put all the information that we have here for it. We know that this is a 40 kip force acting down. This is a tension. It's at 23 degrees. You can look at the geometry, figure that out to this point A here. We have C down here, which is the pin. Pin has two reaction, horizontal and vertical. We're going to call this RCV, RCH. So we also know that the distance from C to A is 10.5 feet measured horizontal or vertically, and then we know from C to the line of action of the 40-foot kip, it's 6 feet. So what we're going to do is sum of forces in X first, sum of forces in X have to equal 0. In X we have RCH, it's an unknown, minus T cosine of 23. That's equal to 0. Gives us RCH is equal to 0.9205 T. So that's unsolvable. So we'll come up here, we'll look at sum of forces in Y. So in Y, we're going to have RCV minus 40 plus the Y component of the tension cable, which is T sine 23. So we can simplify that a little bit, but not resolve it. RCV is going to be equal to 40 minus 0.3907 T. And so again, you got two unknowns here, but they're not the same two unknowns, so we can't solve it. So we have to look at a moment. So moments, where you need to be careful. You got two places that would be good for moments. You can do it at C, knocks out these two, but you got to be careful with the tension. So if you do that, you want the tension to float up to here so that you get the vertical component here that will knock out, and then you'll be left with the horizontal component. So that's a process of using transmissibility. If you took the moment at A, you'll knock out T, you'll knock out RCV, and you'll solve RCH directly. So either way works. I'm going to go ahead and do it at C and use transmissibility. So we're going to say summation of moments about any point have to be equal to 0. Clockwise, we're going to do this at C. So we've knocked out C, H, and CV. We should be solving for T essentially. So we look at that. We've got that 40 kip load at the 6 feet. So it's going to be 6 times 40, tending to turn that clockwise. So when we were up here, we have the vertical component, which is gone, but the horizontal component is going to be T cosine 23 times the distance of 10.5, and that's a negative rotation. So we're going to have negative 10.5 times T times cosine of 23. And all of that then is equal to 0. So when we do that, it will resolve for T. 6 times 40 gives us 240, comes over as a negative 40. Cosine of 23 times 10.5 gives us 9.665. It's a negative, so we're dividing through by that negative. 9.665 negative. and that will give us 24.83 kips for tension. So tension would have to be positive. If you come out with a negative tension, that would indicate that you've got tension going the wrong way, and that's an impossibility. So tension always has to be coming away. So this looks good. We can now float this guy up to here. We plug that 2483 up to here, and what we'll see is when we do this math, that 2483 times that minus the 40 for RCV, we should be getting 30.30 kips, and it's a positive, so it does indicate that we had it going up, and that's correct. So there's one answer. There's the second answer. Taking your 2483 and floating it back into here, it gives you RCH, and you can see the RCH then is going to be 22.86 kips. It's also positive, so your initial assumption was correct. And there's your answers for the three that you have.